Hello Sudoku friends and welcome to a hard puzzle in my Chinese origin puzzle series. This is rated 32 minutes to solve and I am seriously doubting that those numbers can be right because I've never spent 32 minutes on any of these puzzles. This is only rated hard, not very hard. It's got 6 stars instead of 7. I kind of like these grids because they are very good for instructional purposes. They very often show the same kind of patterns that I like to explain over and over again because they really help solving Sudokus. Whether you use pencil marks or not, it doesn't really matter. It's a question of how you think about a puzzle that matters. Don't just look at a number and see what happens. See if you can find out if something is missing and that you can find an easy singleton somewhere. This is not going to give you a lot of successes. What is going to give you successes is looking at this chute here or here or here or these vertical chutes. When you look at 3 rows or columns together, then you start seeing patterns because there is a symbiosis between one box of 3 by 3 squares and a row or a column of 3 boxes, because both the row, the column, and the box need to contain 9 different digits. And there can be no duplicates in a box or in a row or in a column. And that makes it a lot easier to find things if you look at 3 rows or columns at the same time. Take the 2 and the 3 here, for example. Let's just focus on the 3. Instead of just saying, what can I do with the 3 in this column or in this row, take a holistic view of the whole chute here. And now you track this 3 going up here, and you track this 3 coming up here, and you see that a 3 will have to go here or here in row 5. And that leads to the conclusion that in row 6, a 3 will have to go here or here. It's not really important that I know now whether the 3 will go here or here. What's important is that now I know that the 3 will go in one of these 2 squares. And once I have seen that or realized that, I don't really need to think about it anymore. I'm also seeing that this 2 blocks here and the 2 blocks here and this 2 blocks here. So I know now that one of these must be a 2. And taking a view of this chute here, it's easy to see that these 2 6s, they just jump out at me and they block these squares here. And as soon as I see that, I see, are there any ramifications related to these 6s? And there is, because we have a 6 here blocking here, and that makes this a 6. So we found our first digit. And this is, I think, what we call a hidden single, because it wasn't obvious from the beginning. We had to do a little bit of legwork to find this 6. I'm also acutely aware that the 9 and the 5 must find homes in 2 of these 3 squares. There's a 5 here blocking, so one of these must be a 5. And then I immediately look, is there a position where I can place a 5 in one of these squares? And there isn't, because now we have these ghost 5s blocking here. We've got this 5 blocking over here and this 5 blocking down here. So a 5 will have to go in one of these squares. And then I revert back to the 6 here, and I'm looking at the 1 blocking over here. I'm looking at this 1 blocking over here, and I see that there's only one square where 1 can go, and that's here. The next thing I do is I look at the 1, 4, 6, and the 7, and I try to find homes for them in this row up here. And we already have found the 1, 3, and the 7. So now I know that one of these must be a 4. And because we found the 1 here, this 3 now blocks all the way over here and this 3 blocks down here. So this is a 3, making one of these up here a 3. And every time I say, or I think to myself that one of these is a 3, I know that I must find a 3 in these squares up here somewhere, sometime. I'm also now aware that these 3 block here, so one of these must be a 3. And I know now that a 3 for this column 4 must go here, here, or here. It's not something that I really think about. It's just something that stays in memory. Another thing that stays in memory is that this 3, as I mentioned before, blocks here, this 3 blocks here. So one of these is a 3. I think we can agree on that. So now that these 3's block here, and this 3 blocks here, and we've got this 3 blocking here, leaving only these 2 squares for a 3. This square is also blocked. I now see that the only 2 squares in this column not blocked by a 3 are these. So as I said before, when I find out that a 3 has some limitations like here and here, I immediately start scanning upwards to see if that has any ramifications for the 3's elsewhere in the grid. And I really do remember those 2 3's here. And I therefore know that these 2 squares can't be a 3, and this square also can't be a 3 due to the 3 here. So this is how I find candidates. And as you will notice, in most puzzles, I don't see a need for entering any notation at all, not Snyder, because if a puzzle is so difficult that it needs notation, I find that Snyder is usually not going to be sufficient. And that's why I chose to train myself to not use any notation at all. It also makes it less messy when I solve Sudokus on paper. Admittedly, though, there are times when I do use pencil marks because a puzzle can get so difficult that I can't keep all the possible candidates in my mind. So having found that I can limit the 3's to these 2 squares, I'm now aware of the 6 blocking here and this 6 blocking here. So one of these must be a 6. But wait, didn't we just say that one of these must be a 3? So now we have a 3-6 pair. And these are always nice because now I only have to look at these squares to find more digits. I know that these 2 are being spoken for by a 6 and a 3. And this 6 here blocks all the way over here. This 6 blocks over here. This 6 blocks up here. And that makes this a 6, doesn't it? I immediately now scan upwards, and these 2 6's block here. These 2 6's block here. Therefore, this is a 6. There really isn't anything to it. Anyone can do this, I think. It's just a matter of a little bit of a discipline. Now look at the 7 going up here and the 7 coming down here. The more digits we find, the more we can restrict the possible candidates for other cells. And this is the only cell that can be a 7 in this column. And remember how we said that a 2 would have to go here or here? Now the 7 here blocks over here, the 7 blocks over here, so this 7 blocks over down here. So now we know that 2 of the 3 digits here must be a 7 and a 2. At this point, when I have in a row or in a column 5 givens, I often find a digit by just counting the remaining 4 digits and saying what can they be? Well, they have to be a 1, 2, 4, and a 9. This 2 blocks here, this 2 blocks here and here. Therefore, this must be a 2. And now one of these must be a 2. The 3 remaining digits were a 1, 4 and a 9. We have a 1 blocking over here. We have a 1 blocking over here. So this is a 1. These two now have to be a 4 and a 9. I can't place them yet, but now I know, and I don't really have to waste another thought on those. A 4, 5, 8, and a 9 still for these empty squares. The 4 must, because of the 4 here, the 4 must go over here somewhere. So this is a 5 and an 8, making this a 4 or a 9. We also had a 4 or a 9 over here and here. So, but they are really unrelated. So I can't use this for anything. It's just mildly interesting. I don't remember if I mentioned it, but the 5 blocks up here and the 5 blocks up here. So one of these is a 5. Therefore, one of these must be a 5. I could begin looking for 5s in those 4 squares here, but the only thing I can say with certainty is, oh, hang on. We got a 5 going over here and a 5 coming down here. So this is a 5. Just talking about this helps me find digits. But then one of these 3 squares must be a 5, and that's a little bit too much to cope with. Now one of these must be a 5, and the 2 others must be an 8 and a 9. Let's see, 8 up here. No, well, there's a 9 going over here now, right? So this is a 9, yes. And this is therefore the 4 that we were talking about earlier, and that makes this a 4. See how easy this is? Just talking about it finds the digits. Isn't that amazing? So we are slowly filling up the left chute in this grid. By the way, I'm also noticing, remember how I said that the 5 blocks up here and this 5 blocks over here, so one of these is a 5 and therefore one of these is a 5? Let's keep those 2 squares in mind, and then now we look at the 5 blocking over here and the 5 blocking over here, and that means that these 2 must be 5 candidates. And that tells me that only these 2 squares in this column can be a 5. It's not super helpful right now, but it's something that I will keep in mind. Because now I know that a 5 for this row here must go here or here. Now I'm getting creative. I'm looking at the 2 and the 1 here and the 2 and the 1 here. We need to find a 2 and a 1 for these 3 squares. And look at the 2 and the 1 here. So the 2 and the 1 can't go here. The 2 and the 1 must go in these 2 squares. Oh, so we have a 5, 8, and a 9 possible down here, and we have a 5, 8, and a 9 possible here. So not really being able to find the next digit easily. I'm now counting these 3 squares. And they have to be a 2, 3, and a 7. And look at that. We have a 2 and a 7 in this column. That makes this a 3. Now the 3 blocks down here, this 3 blocks over here, so this is a 3. And these 2 now have to be a 2 and a 7. We also shouldn't neglect these 3 rows up here. There's a 7 here, and there's a 7 here, and that puts a 7 in this empty square. And just as things are becoming more desperate because it gets increasingly difficult to find new digits, we have to look at intersections between rows, columns, and boxes. One easy way to perhaps find a digit is to look at these 5 empty squares. They look daunting, but look at what we are missing. We are missing 2, 3, 4, 6, and a 9. Now look at this square. It can be seen by a 2, 3, 6, and a 9. So the only possible value that we can enter here is a 4. Remember how these two had to be a 4? Now the 4 blocks down here. So this is a 4 that has to go here. And now I think we need to look at these 3 squares again. They have to be a 5, 8, and a 9. We have a 5 and an 8 blocking here. So this is a 9. These are now a 5 and an 8, making this a 9. So these are now 5 and 8, yes. And there is a 5 in this column, making this an 8 and this a 5. Now we just need a 2, 3, and a 6 for these 3 empty squares. There's a 2 and a 3 blocking here, so guess what this is going to be? That's right, a 6. And remember the 3, 6 up here? This is now a 6 and this is a 3. And therefore this must be a 2, making this a 2. Making this a 1 because you remember we talked about the 1, 2 here, right? So this is a 1. These two ones blocking like so, and these two ones blocking like so, making this a 1. I feel there must be a 5 somewhere. Let's see. I'll have to get back. Well, a 5 was going to be in one of these two, right? But I still can't place it. But a 2, 7, and 8 for these squares. Okay, so there's a 2 blocking over here, so one of these is a 2. And we have a 2 up here, so we need to place a 2 in one of these two squares. And we have 1, 2 blocking here, so this is a 2. 5, 7, and 8 for these. There's a 7 blocking over here, so this is a 7. That makes this a 7. And therefore this must be a 7. And therefore this must be a 2. And remember that we had these two blocking here and here. Now we have this blocking here, so this is a 2. This has got to be an 8 because it's the last digit missing from the box. Making one of these an 8. You remember what the other one was? Yes, that's right, a 5. Making these two a 9 and a 4, which I can't place yet. These must be an 8, which can't go here because of this 8. So this is an 8. And this must be a 5. And remember how one of these had to be a 5? Now this can't be a 5. Therefore, the 5 goes here. This last digit has got to be a 9. So that makes this a 9, doesn't it? And this must be a 4. These two have to be an 8 and a 4 now. They will have to wait just a few minutes longer. Only one digit missing here, and that's an 8. And that makes this an 8. Still 5 and 8 here. These now have to be a 3 and a 9. There must be something else easy. 3 and a 9. We have, okay, let's look at these two squares. They have to be a 3 and a 5. We got a 5 in the row, making this a 3, and this a 5. And the 3 here solves our dilemma here. This is now a 3 and this is a 9. Making this a 9. And making this a 9. And this now must be a 4. This must be a 5, making this a 5 and this an 8, because we talked about that at length already, didn't we? This is now an 8, making this a 4. This is a 4, and this is a 3. This was another slow walkthrough of a hard puzzle. As I hope to have been able to demonstrate to you, it isn't really hard at all once you put your mind to it. It's just a matter of a little bit of logical thinking and reasoning, and you're home free. Thank you for watching, and bye for now.